It's 9:57, so we've got a few minutes. So maybe when we're waiting, Rafael, maybe you'd tell us a wee bit about yourself and how and your journey to Maynooth University.
Sure, yeah, that'd be great. So my name is Rafael de Andrade Moral, and as you can tell by my surname, I'm not Irish. But en route to naturalization, I am married to an Irish woman, and I've been in Maynooth since 2018. As I'm going to say over the next few minutes, my initial background is not actually in statistics. I'm a biologist by training, but I started working with statistics from my second year in my undergrad onwards. And it was great because I was actually not sure whether I wanted to do maths or biology when I was in the equivalent to the Leaving Cert in Brazil. And I remember asking my mom. My mom, she was a maths teacher. She's retired now. But I asked her, Mom, what do you think I should do? Should I do maths or biology? And there was a college that had a biology course right in my hometown, and there was no college with maths degrees. And my mom didn't want me to move away, but she gave me a very good reason. She said, well, you should do biology because you can then study some maths on the side and join them and do some applications in biology. And that was great because that's what I've been doing since 2008 now. And
your mum, Rafael, your mum sounds, just anyone who's joining us, we have a couple of minutes to go. So I'm quizzing Rafael here on his journey to Maynooth University. My name's Ita. So Rafael, I'm just smiling to myself. Your mum sounds very much like an Irish mum. Any queries we get into the admissions office for students considering studying at Maynooth, it's usually from Irish mothers wanting to know more information. I'm sorry to say, it's usually for their sons. So I'm laughing that that it's the same. It's the same with in Brazil. Your mother must have some Irish heritage in her somewhere.
I actually took one of those DNA tests, and I'm 13% Irish, actually.
Wow, wow. Can I just check, Rafael, that recording is going ahead there? Yeah.
It is, yeah.
Brilliant, brilliant, because we've had some schools just to say that some of their fifth year classes can make it and their other fifth year classes are in class. So they don't want to miss out. So Rafael, it's 10 o'clock, but just, we're so excited that we've had over, 70 schools registering for this with an attendance of over 2,500. And we've schools from the Aranmore Islands in Donegal right down to Kenmare. We've some from, you might notice a bit of a twang from my accent. I'm from Monaghan, so I'm delighted that we've representation from Monaghan. And we've schools from nearly every single county in Ireland. So are you feeling the pressure, Rafael, or how do you cope with the pressure?
Oh no, it sounds great. That's lovely. I'm actually really excited that there's been so much interest in some maths and some stats and talking a little bit about our superpowers as I titled this presentation. No, I'm very happy.
Yeah, and just before we kick off, I noticed the guitars in the background, and yes. I was looking at your YouTube channel, and we put a link up in the chat room to your YouTube channel. Tell me about how you managed to marry the passion of music with your passion in statistics.
Oh, well, it started when I was like 16. I had my first band, and they wanted to play rock and roll and heavy metal and so on. But then during my master's and PhD, we had a band within our friends in the stats PhD degree. So we're all statisticians in the band, apart from my uncle, who was the bass player, and he's a historian. But we would play around and play some gigs here and there, and also study stats. And when the lockdown came, and I was recording videos for the students. I was recording a video on a quick recap on some probability theory, some formulae, and so on. And I was just speaking through the formulas, and I was like, that doesn't sound very appealing. Like, I wouldn't really watch myself talking a bunch of formulas over 5 minutes. So I was like, maybe I'll sing it. So I asked a friend of mine, I was like, what's the cool song of the moment? And I was like, oh, that's Billie Eilish, Bad Guy. I was like, okay, I can write a parody on that. So I did. And I put the video on. I had nothing to do on a Sunday. I recorded my bunny. So we have, myself and my wife, we have 2 bunnies and 2 dogs. At the time, we had only the 2 bunnies. So I recorded them playing the tin whistle, and I put them in the video. So I guess that was the big thing about the video. Oh, we want more bunnies. We want more bunnies. So I recorded them.
Yeah, well, I just let the attendees know before I hand over completely to you, Rafael. I didn't know Rafael until I think it was our April open day, Rafael, and it was a virtual open day, and I was kind of monitoring the STEM talks, and you were on in the background, and I was listening to you, and I was like, oh my goodness, this man is amazing. I actually want to go back and study as a very mature student a degree in maths at Maynooth University because my background is engineering and now I work in admissions in Maynooth. But you're really, really inspiring. So it's 3 minutes past 10. I'm just going to encourage people to use the chat button or the Q&A. I'm in the background to answer any of those. And if you raise your hand, Rafael has given me a sneak insight into what he's going to be covering. So he's going to ask for some participation. Please don't be shy. This is being recorded, but no faces are going to be shown. And we would encourage you, if you're a dab hand at social media, I must admit I'm not a whiz kid, but I can do an odd tweet or two. But don't forget to use our @Maynooth CEO Twitter handle, and we'll retweet. And I'm going to hand over to you. But Rafael, I'm so excited. Thank you so much for your time. Thanks very much to all who have logged on so far. And this will be recorded. And Rafael, I'm going to put myself in mute now, or I could end up talking for the full hour.
No worries. Thanks very much, Ita. I'm just sharing my screen now. Could just confirm that you have the screen share there.
Yep, that's good.
Awesome. Thanks a million. So good morning and welcome everybody to this talk that I affectionately called "Do Statisticians Have Superpowers?" I know I'm a bit biased, as you're going to see over the next hour or so, that I really love statistics, and I actually really love biology as well. As I was saying a few minutes back, my undergrad was in biology back in University of São Paulo in Brazil. And then I did a master's and a PhD in statistics. During my master's and my PhD, I spent a while in Ireland. And then January 2018, I moved here for good. I got the job in Maynooth University as a lecturer or assistant professor of statistics. And I also married Sonia, my Irish wife. So I'm here for good now. And so welcome and thanks very much for joining. So I'd like to actually go straight to the point and start my talk by actually answering the question. So do statisticians have superpowers? So that's the answer. Yes, we do. Thank you very much. I'll take your questions now. No, I'm joking. So yes, we do have superpowers, but I'll actually tell you why and why these are maybe what I call real world superpowers instead of the ones that we see in the movies, right? But we can get close. So maybe some evidence to support my claim. So today, I'm going to talk about this again over the next few minutes. Statistics is about looking at evidence to support claims, right? We generate hypotheses in every field of science. We will generate hypotheses. We can translate those hypotheses to statistical hypotheses, and then we collect data. Without data, we're just saying what we think, and what we think may not be true. So if you want to look for objective truth as scientists, then you need data to support your claim, or you need evidence. So for example, there in weather forecasting, I'm pretty sure everybody there, or most of you, have a smartphone, and you can check the weather like this with something that looks a little bit like this, or a variant of this, and you can say, all right, so over the next while it's going to rain. There's this particular chance of raining. Tomorrow it's going to be 20 degrees, but the day after is going to be 25 or 18 or whatever. How does that work? Well, there's lots of statistics, data science, machine learning, artificial intelligence, you name it. Those are very trendy buzzwords at the moment. We're going to talk a little bit about that. Machine learning, artificial intelligence, big data. They're all very, very trendy buzzwords at the moment, but we're going to try and explain in a nutshell what they actually mean and what we do when we tell people that we do that. Actually, typically, this is what happens when I tell people that, oh, I'm a statistician. I work with lots of formulae and numbers, and I fit models. If I say that at a social gathering, people will kind of go away from me. But if I actually rephrase that and I say, well, I'm a data scientist and I work with machine learning and artificial intelligence, they're like, oh, wow, do tell me more. So, I mean, they're very similar fields. In fact, they could be overlaid pretty much, but there's some differences here and there, of course. But data scientists, statisticians, we all work with data, and we're all trying to get insight from data. So sorry, I digress. As you're gonna figure out, I'm very thrilled about this, so I will digress quite often. So yeah, if you have a weather forecasting app on your phone, stats and data science go into that, as well as mechanistic models in geography or meteorology, for example, right? So you see the temperature that comes before, that comes in the past, and you see the patterns that happened years ago, and you try to predict what's going to happen tomorrow and so on. But more importantly than simply telling you, oh, probably going to be 20 degrees, more important than that is telling you how certain I am of saying 20 degrees. So instead of saying 20 degrees, I might actually say, well, it's between 18 and 22, and I say that with 95% confidence. Well, that sounds much better, right? And that's statistics and data science helping you achieve that. In scientific research, every single scientific paper has to have data to support some claim, has to provide evidence or to test a hypothesis. You need statistics, you need statistical techniques, mathematical tools, data science tools to actually make sure that what you're saying is real. And I just skip for a quick second. If you go to medicine, for example, now that we're doing the COVID-19 vaccinations and so on, so many data that arose from those clinical trials. So we actually can say that these vaccines do work. It's not a placebo effect. We have to use statistical tools and to draw insight from that data. What I'm saying, public policy, and also that guides public policy. The restrictions and the measures that were put in place all over the world, they were all, or most of the time, and for most countries, they were not dictated, but we created mathematical models that would try and predict how the spread of the virus was going to happen, how many people would be infected after a month or 2 months if we put some measures in place, if we did, and so on. And that can guide public policy. So not only in healthcare, but in all sorts of public policy as well. The stock market, I don't know if you've heard about the GameStop phenomenon that happened earlier this year. So all of a sudden, the value for GameStop just skyrocketed, and people who had stock there, they made millions. If you knew it was going to go up like that, of course you would buy it. So there are statistical models that we call time series models that try and predict the behavior of the stock market, for example, and other things. If you've ever or if your parents have taken out an insurance policy, they have to pay a premium. And how do you calculate that premium? It's based on the probability of having to pay the person for maybe crashing their car and so on. That's why, depending on the biological sex, depending on the age, etc., these premiums vary, and so on and so on. So there's many other applications. We will touch on some of them today. But the main thing that I'd like to say, and the main message that I like to pass today, is that you can use mathematical and statistical tools to simply predict the future. And this prediction is not simply a single prediction, 20, 5, whatever. No, you also quantify the uncertainty around that prediction. And this is key, and it's extremely important, and it affects us everywhere, right? So why mathematics? Why statistics? Well, we know that nowadays, of course, a basic proficiency in maths is essential. So everything that we see, everywhere we look at, we are surrounded by applications of maths and stats, not only the ones that I've just mentioned, but others. But you can see here, for example, in this brand that you mightn't know which brand this is, but I'm pretty sure you do, 9 out of 10 dentists who tried would recommend it. And then you look at the small right in here, independent survey. What does that even mean? Was it hired by the people who are trying to sell this? Maybe that's not really independent. What do they mean with independent? That was April 2011, so maybe it's changed now. Maybe nowadays it's only 5 out of 10. And look at this, N equals 77. So basically what they're saying here is that 90% of the 77 said who tried, right? Maybe some of them didn't try. 90% of the ones who tried out of these 77 would recommend it. But would they only recommend it, or would they recommend it in a pool with others that are pretty much the same? How can you trust facts that I've thrown to you like this. Nowadays, fake news and social media, social media is full of fake news. How do you make sense of them? You need some background knowledge in maths and stats to make sense of this, to be critical and try and understand what they're trying to tell you, and if there's any reasoning behind it, right? Well, again, we make very important life decisions based on maths and stats, not only on toothpaste, but we make very important life decisions based on this. Every time you choose to go inside a car or to go on a plane, you're making a decision that might be safe for you. There is, of course, a tiny percentage or a tiny chance that it might go wrong, but because most of the time it doesn't go wrong, you're making a decision that, well, I will take this risk because I think the benefits outweigh the risks. The risks are very small. And also, we all have problem-solving skills. We evolved our prefrontal cortex in the brain to solve problems. So we can do that. That's another good reason to actually do it. So I'd like to do a quick demonstration here about, well, we're going to look at probabilities, but we're going to do a demonstration of coincidence, maybe, and then we're going to see what the chances are and try to check whether there's any correlations or causal relationships. So for this particular demonstration, I'm going to stop sharing the screen for a second, and I'm going to use a deck of cards. So this deck, we have 52 different cards. I'm going to need a volunteer from the audience, somebody to raise their hand, and then Ita will unmute that person, and they can name. All I need is for you to name one playing card out of the 52. We're going to try and just shuffling the deck here, trying to do a demonstration on coincidence, maybe. Just put the deck here. Yes, there's somebody there. Maybe
Yeah, sorry, Rafael, I actually can't see the raised hand, so apologies.
Okay.
I was supposed to be your assistant, but I'm not doing a good job.
No, that's okay. That's perfect. I'm just gonna so I'm gonna let the first person here raise their hand speak. So I need to promote to panelist.
I see it now, Rafael. Apologies. Yes.
No.
So do you want me to do it? So
No,
I'm gonna pick out Aaron.
Oh no. Oh, sorry. Oh, okay.
Allowed to talk? Yeah. Yeah, Aaron.
Hi there.
Hi,
Hey,
Aaron.
How's it going?
Good.
Right, so do I have to guess the card or?
You just name any playing card out of the 52.
Ace of Spades.
Ooh, the Ace of Spades. Okay. So just before we actually continue, do I know you, Aaron?
I don't think so, no.
No. Okay, good. So this has not been, well, maybe, I don't know. I'll explain some reasons why. Okay, so the Ace of Spades. Now, what I'm going to do, so I have the deck here that's thoroughly shuffled. So what I'm going to do is I'm going to open my chronometer app. So maybe you can see this. Maybe you can spotlight myself. Spotlight. There you go. Come on. There you go. You see minutes, seconds, and so on.
Yeah.
So if I actually spin the seconds wheel, it will land at a random number between 0 and 59. So you see, if it's landed on number 1, if I spin it again, number 50. So I'm going to spin it one last time and see the number it's going to land on. Oh, come on. It's not showing. Come on. Ah. It landed here on the, I can see it, you have to believe me. There you go, number 11. It just showed there briefly. Okay, it landed on number 11. So 11, those were 60 options, it landed on 11. Aaron named the Ace of Spades, 1 out of 52 options. So let's open the deck. And what we're gonna do is we're gonna count to the 11th card, okay? So this is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the 11th card is in fact the Ace of Spades that Aaron just named. And as I showed before, every card is different. Okay, so that's a demonstration. Well, it's a magic trick, but it's also a demonstration of coincidence, right? So you can say, well, that's a huge coincidence. Let's actually calculate. Where is my? There you go. let's calculate how likely it was for what you just seen to actually happen, right? Can you see my screen again, Ita?
Yes, we can. Thank you.
Okay, perfect. So look, a random card from a deck of 52. That's 1 in 52. That's the chance, right? A random number between 0 and 59. That's 1 in 60. So what we just witnessed here, this demonstration, the odds of that happening by chance alone are 1 in 52 multiplied by 1 in 60, because we're considering these two things to be independent, right? The naming of the card and the number that we get from just flicking. So that's 1 in 3,120, or if you wanted to convert to a percentage, it's 0.03%. So extremely slim, extremely tiny, and that's why it makes a good magic trick, right? And if you like magic tricks like I do, there's that show, Penn and Teller Fool Us. That's pretty cool. You can see the magicians try to fool other magicians. So basically what happens there, the chances are so small that we say, well, there has to be some trickery going on there. It can't be just coincidence. It can't be by chance. So imagine there's a claim. The claim is, what I just did here, what we just did here, this is no trickery. It just happened by chance. So now I can ask you, does the probability we calculated, does it support this claim? Or maybe there's evidence to reject this claim in favor of an alternative explanation. I would say that the probability is so small that there's evidence that we would reject it. Well, no, this is trickery. Okay, I'm going to reject the claim that that just happened by chance. It didn't. I had to do something here. Maybe Aaron and I met an hour ago and we said, no, you're going to name the ace of spades or whatever. Anyway, whichever explanation you can find, right, that there is some trickery going on here, we would reject the claim that there is no trickery in favor of that one, because the probability of this happening by chance is so small. And this is pretty much what we do when we carry out hypothesis testing in statistics. So sometimes people are afraid of studying hypothesis testing or statistical inference. Those are just names to things that are actually very intuitive. If the chance of observing that phenomenon it's very, very slim at random chance, right? If the probability of observing that is very slim, then there might be something going on. So if we transport this to say, let's talk about the COVID vaccine, for example, yeah? Some people got the COVID vaccine, some people got a placebo. So you look at the reduction of the incidence of the disease or deaths or etc. in one group versus the other, and you calculate the probability of that happening by chance alone. And because it's very small, we say, well, there is an effect of the COVID vaccine. It protects. Okay, so that's pretty much what we do. And now an example of coincidence, okay? So imagine you receive the following email. Oh, hello there, I've devised a computer program. It's based on a machine learning algorithm. It's a very complex machine learning algorithm, right? And that can predict the outcome of a GAA match, which is 100% accurate. It's gonna tell you whether a particular team you choose is gonna win, lose, or whether they're gonna draw. And imagine how much money you can make by betting on the correct outcome. And I'm willing to sell you one of a very limited number of copies for a modest sum of 1,000 euro. If you receive an email like that, would you pay 1,000 euro? Well, not really, because there's no evidence to support the claim that this person's making, right? But then they say, still not convinced, I'll send you the first prediction for free. In fact, I'll send you one free prediction every week for the next 5 weeks. And when you see that I'm 100% accurate, I can guarantee you'll be praying there's still a copy left. So you received this email just before GA season began. You wouldn't really have taken the offer. But what if the first prediction had been correct? Would you have taken the offer then? Well, it could just be luck, right? Just win, lose, or draw. So no, maybe just be luck. Okay, what if the second prediction was also correct? What if the third, fourth, and fifth, what if all 5 turned out to be correct? What is the chance that that happens, right? It's kind of a slim chance. So maybe they have a machine learning program that does that. Yeah, that's too coincidental to deny. Well, I'll tell you how that can happen, in fact. How would this work? So this person maybe sent this email to 1 million people. I'm just putting 999,999 so we can split into 3 groups, okay? They send it to almost 1 million people. To a third of them, they sent a prediction that the team would win. Another third, the team would lose. Another third, the team would draw. And imagine that the team won. What did they do? They just discarded 2/3 of their audience. It's like, okay, we predicted something wrong. Let's focus on the group that we got it right. And then they split them again. 111,111. They say win, another third lose, another third draw. And keep going for 5 weeks. After 5 weeks, out of approximately 1 million people, there's still 4,000 people who got all 5 predictions correct. Now, imagine that only 5% of this 4,000 will actually pay for the software. Then the scammer would make over 200,000 euro. Yeah, on the basis of a lie. But then you can ask yourself, why would people fall for such a scam? Well, number one, they don't know that the person is sending 1 million emails about it. Number two, we have evolved to try and find patterns in things. And there was a fairly impressive pattern here, right? And also reinforced by maybe greed and the desire to get something for nothing. Like when it sounds too good to be true, it probably is. So think about all the times that you've had astounding coincidences. Like I think one of them, coincidences happen all the time with me and my wife. I'm singing a song and then she arrives home from work and she's singing the same song or something like that. But then there could be an explanation. Well, number one, maybe we both heard that song on the radio a few hours before, or maybe we're just a very well suited for each other that we like the same songs and so on, right? But think about all these coincidences, and we actually stop to think how many opportunities for coincidence there are. We typically notice one extraordinary event, the occasional collision, but not the millions of near misses. A background and an understanding of statistics, probability, mathematics, chances. This helps us make sense of the world and maybe not fall for a scam like this. Yeah. And that's what I'm just trying to say here. Maths and stats, they help us make sense of the world. And just as a quick fact, and I'm going to try and do a quick demonstration in a few minutes, humans are typically very, very bad at predicting randomness. So typically, if you ask somebody to name random stuff, they're probably gonna they're not going to name random stuff. There's a definition of randomness in statistics and probability theory, and it depends on different distributions and so on. But humans are typically bad at doing this. Just trust me. And sometimes results, or sometimes maybe a lot of the times, results are very counterintuitive. And I'm going to show one example here today as well. So that's why we use maths and stats to help us make sense of this. Okay, we can trust the maths and stats. It's if our assumptions are correct, of course. So to explain patterns, to predict events, this helped us survive and thrive as a species. Imagine thousands of years ago, we wanted to know when are the plants or the fruits, or when are they going to start growing again so I will have food? When will the herds reappear so I can have food again? Do we have all of our stuff? You know, how many did I have before and how many do I have now? Oh, somebody steal it or did I miss it? Whatever. So we need to make sense of the world using those tools. So just as a quick example of maybe how bad we are at predicting randomness, right? So this guy, John Edmund Carrick, he was an English mathematician, and he was put in jail during the Second World War. So the Nazis they occupied Denmark in the 40s, right? He was actually visiting his in-laws, and then he got put in jail when they invaded Denmark. And since he was in jail, he was a mathematician. He was like, well, maybe I'll make my stay here a bit productive. So he had a fellow internee called Eric Christensen. He was trying to show or to experiment on laws of large numbers. Like if we keep running the experiment again and again and again and again, are we going to get the results that we predict we would get? So a quick experiment you can do is just toss a coin, flip a coin, heads or tails. We say that there's heads and there's tails, so the probability of getting heads is 50%. The probability of getting tails is also 50%, 50-50. So what they did, they tossed a coin 10,000 times and counted the number of heads that they had. So you can see here a plot of the first 2,000 tosses, okay? And this is the proportion of heads in the y-axis there. So at the start, they had a tail, so there's 0% heads. And then they had heads, so there's 50-50. And then it kept going up and down, fluctuating up and down, and so on. And as the numbers grow, Yeah, it fluctuates around 50%. And in the end, I think he got 5,040 heads and 4,960 tails. So really, really close to 50-50. But that doesn't mean that just because I've had a lot of heads, then the next one has to be a tail, because the universe has to somehow compensate for that. That doesn't happen, okay? The same thing with the lottery. Some people play the lottery like this. Oh, numbers 13 and 20, they haven't come out over the last few draws, so there's a higher chance they will come out now. No, that's not how it works, because every single draw is independent, right? So just as a quick exercise, I'd like you to think about these two sequences, okay? So these are sequences of heads or tails. One of them is a real sequence of heads and tails that somebody tossed and called out, heads, tails, heads, tails. The other one is a random sequence. It's a fabricated sequence, okay? That a few years ago, I asked some of the students in a statistics class to just name what they think would be a random generated sequence of heads and tails. Can you spot which one is the imposter? Which one is the true sequence that was obtained through experimentation? And which one was named out loud by humans trying to predict randomness? So I don't know which one you thought was the imposter was, but most people, I asked this too, including myself, okay, when I saw this first, would say sequence number one is the imposter. Because look, there's so many heads appearing one after the other here, and then again here, and then again here. You see, that's not random. Sequence two, oh, that's much more random. Look, heads and tails kind of equally interspersed. If there's a lot of tails, then you compensate with a head. And then if there's too many heads, then you compensate with tails, and so on, right? But in fact, sequence number one is real. That was obtained through experimentation. Sequence number two was called out by students. We're trying to create something random. So that's one of the many examples we can give, or the many exercises that humans are really, really terrible at predicting randomness. Again, just because we have many heads appearing, it doesn't change the odds of getting heads or tails the next time. The universe isn't somehow magically going to compensate for that. So let's talk about a very counterintuitive probability problem. Okay, so we call this the Monty Hall problem. It's a game show, right? Where the game show host gives you 3 doors, and they say, right, behind one of these doors there's a car, and behind 2 of these doors there's a goat. You've probably heard this before. And then you say, okay, so you got to pick one door. So imagine you pick door number 2. Then the game host goes and he opens, or they open door number 3. And they say, look, behind door number 3, there was a goat. Well, now you know that there is 1 car and 1 goat. And then they give you a chance to switch. Yeah. Do you stick with door number 2 that you picked at first, or do you switch to door number 1? Now, it is counterintuitive to say that switching would give you any advantage, because look, there's 1 car and 1 goat. So it doesn't matter which door if you switch or if you stick to the door that you picked before, it doesn't matter. It's 50-50, right? Wrong. If you actually calculate what we call a conditional probability here, you would see that if you switch, that would be advantageous to you. So let's just show you why. So you're asked to choose a door. So you can either choose a door with a goat, the other door with the goat, or the door with the car, right? If you pick a door with a goat and you stick with your choice, you get a goat. But if you change it, you definitely get a car, because the host opened another goat, or the door with another goat. But if you only win the car if you have chosen the door with the car to begin with. So if you look here at the probabilities here, if you change, conditional on you changing 2 out of 3 times, you see the pink ones, you get a car. And conditioning on you sticking with the first choice, 2 out of 3 times, you get a goat. So if you change, there's 2/3 probability that you will get the car. And to make this even more, let's say, make this greater and maybe easier to understand, imagine instead of 3 doors, you had 24 doors. Behind 23 of these doors, there's a goat. And behind one of them, there's a car. Imagine you pick door number 2. and then the game show host goes and opens every other door apart from door 21 to show goats. Would you stick with door number 2, or would you switch to door number 21? Well, it's way more likely that you chose a goat to begin with. So if you actually switch, it's 23 out of 24, the chance that you will get a car. So of course you will switch. So that's another way of explaining this. And this brings us to maybe definitions. So what is statistics? Well, that's about collection, presentation, analysis, and interpretation of data. What's data? Well, it contains information, but it's not information per se. It needs context, right? And we're going to talk about that in a second. And usually this happens when we have some inherent variability. I like to joke and I like to say that if things weren't random, if there was no variation in the world, I wouldn't have a job, because then there wouldn't be a use for statistics or for probability theory. And probability is the mathematical framework that can describe or model this uncertainty. And that's why it's so important. We have a couple, just as the origins, right? So statistics comes from Latin. Statisticum, it means from the state or of the state. So it means to analysis of demographic data, pretty much of a state of a country. And with the development of science, then probability theory, IT, informatics, statistics, then there's a scientific status that came over the last couple hundred years or so, and then applications in virtually all areas of knowledge, right? And a few definitions here that I like. So the science that teaches us the political context of every modern state in our world. So really bringing in that origin from Latin. So that is the 1717. In early 20th century, the study of populations, variations, data reduction. If you have too much data and you want to reduce that into one single estimate, for example, yeah. Quantitative data affected mostly by a multiplicity of causes or variation, etc., etc. But I really like this one from David Cox, 2016. It's the science of learning from data. How can we learn from those numbers? Data is not only numbers, right? Data can be names as well. The data can be images, videos, and so on. And then we're learning from data. But what is data science then? Right? I have an example here. Data is everywhere. Data is a set of values. It can be numbers, measurements, descriptive characteristics. Say the color of my hair. That's data. Right? The type of shirt I'm wearing, the number of guitars I have, and so on. But data only becomes information when you have the context. So, for example, what do you think the following numbers mean? 1,989, 2011, 2017, 2020, and 1,000. What do you think that means? Well, it is data, right? It is. But unless I tell you what they mean, unless I give you the context, you won't know. You can't do anything. You can't extract information or any insight. So now I can give you some context. So 1989 is the year I was born. 2011 is the year I graduated from college. 2017 is the year I finished my PhD. 2020 is the year I was supposed to get married, but we postponed because of the pandemic. And 1,000 is the number of grams of chocolate I ate yesterday, which was my birthday. So there you go. These are all put into context. They're numbers that refer to me. So because of those numbers, now you can extract some insight. Oh, so he was born 1989. Oh, okay, so he's 32. He ate 1,000 grams of chocolate. He likes chocolate, and so on. Right? That's the idea. With context, you can extract information. And just as giving you some context here and some examples of what we do. So look at the map of Ireland here on the left panel. This is the worst case scenario projection for 2100 if the sea levels continue to rise with this, at the worst possible projection. You see that many areas in the island of Ireland will be submerged by the ocean. But if you're planning on coming to Maynooth to study for your degree, you see that Maynooth here will not have been submerged, even the worst case scenario. But anyway, jokes aside, if you've seen the IPCC report that came out a month or a couple of months ago, it is worrying, and it's good that it's out there, and maybe that's why we should do something about it. And there's plenty of colleagues here in Maynooth that are working with climate change and climate change data as well, including brilliant statisticians that are trying to solve this problem and help mitigate somehow. Another example here that I really like, coming from the biological realm, this is the Sumatran rhino. The Sumatran rhino is a critically endangered species, and Can you guess how many Sumatran rhinos are there in the world? It's fewer than 80 Sumatran rhinos, fewer than 80 individuals. So they're critically endangered. What can we do to conserve these species? What can we do to preserve? What sort of management can we apply? This is another example, and I did some studies with bald eagles a few years back. And this is a picture taken by a candid photographer kayaking near Prince William Sound in Alaska, and he saw a bald eagle trying to eat a seagull. They do that when there's environmental disturbances. They typically eat fish, but they will attack other birds when there's environmental disturbances. So that's an index of disturbance. So we can go and measure, count the number of eagles we see, look at trends and so on, and monitor. And this particular picture here, I affectionately nicknamed the bird sandwich, because we have here one of the buddies of the gull trying to peck the eagle so it would release it. And then if we look at the full, I'm not going to go in detail here, but if you come and study stats and data science with us in Maynooth, you will get the full picture over the course of your program anyway. You start by asking an interesting question. What is your goal? You know, what would you do if you knew it all? So you start with a question. Always ask questions, because that's how you can actually do something and produce societal benefit. Then you can go and get the data, explore the data, make pictures. If I can give you 3 tips for being a good data scientist or statistician right now, it's number 1, make a picture. Number 2, make a picture. And number 3, make another picture. We are visual creatures. Before we do any complex machine learning or modeling, etc., we need to look at what we have. We need to take a look. And then finally, you can be the greatest data explorer and modeler in the world. If you can't communicate your results and show a picture and tell a story, then nobody's going to want to listen to you. So here in Maynooth, it's our duty to actually teach you not only how to ask the questions, how to set up the goals, how to sample data, how to explore and model, but also how to communicate and visualize the results. And as I was talking about visualization, just as a quick aside, humans are visual creatures. So look, this is an example of what we call pareidolia, right? You look at these pictures, you see an eye, you don't see a drain. You see that this beetle is very, very cross, even though beetles don't have faces. And you see that these shoes are kind of planning world domination, even though they don't have any awareness. And I think that this is a montage, because it really looks like a horse made of clouds. But there you go. We're programmed, we're hardwired to see things, to see patterns. So whenever you can explain using drawings or using pictures, please do. So I'd like to tell you now a short tale about a data scientist. He was never called a data scientist while he lived, but he was one. And I'll tell you a tale of a data scientist who solved a massive public health problem without running any algorithm, without using any computer. And I think that that's class. So, and just to give you some context, cholera is a disease that spreads through contaminated water, gives you strong diarrhea, may cause severe dehydration in very few hours after contamination. It's caused by a bacterium, and it can survive in water for a very long time, like months. But before the theory of germ disease and that it started, people believed that disease was transmitted via polluted air, that they would call it miasma. It's like a shadowy thing that would come and infect you, right? So we didn't know about microorganisms at the time. What happened? This guy called Jon Snow, and I know what some of you might be thinking. It's not this Jon Snow. It's this Jon Snow. And if you're interested in learning a little bit more about him, there's actually a Jon Snow Society. He is known as the father of epidemiology. Epidemiology, which you might have heard a lot over the last few years because of the global pandemic. So what happened? There was an outbreak of cholera in the Soho district in London, okay? And in the 1800s. So you see all of a sudden there's a spike in the number of deaths of cholera. So like over 100 people died in one day, and that's a lot. If that's a lot nowadays, imagine 150 years ago, right? So what happened? He created a figure of that particular district. So this was the Broad Street. So you can see Broad Street here. Cholera epidemic, right? It was part of the cholera pandemic that was going on worldwide. He put bars to reflect number of people that died of cholera or that were infected with cholera in each household. And I have a different plot here that you can see better. So there's the size of the bubble is the number of people with cholera, and the blue taps are water pumps. So looking at this plot here, John Snow was like, look, it seems to me that there's lots of cases around this particular water pump. And these other pumps here, there's nothing really there. So there could be something related to the water. And he was right. At the moment, two companies, at the time, two companies supplied the water for London, Southwark and Vauxhall and Lambeth. Some regions were both supplied water, some regions were only one of them supplied water at a time. And you look here at this particular company, supplied water to 40,000 houses and was associated with 1,200 deaths from cholera. So that's 315 deaths in each 10,000. And the other company, it's 0.37 deaths in 10,000, right? So there's definitely something going on with the water supplied by this company. Then carried out an investigation. They figured out they were taking water from polluted sections of the Thames River. And that was pretty much the founder event of epidemiology. So his plot was very simple, but brilliant. By looking at this, it was like, there's something going on with the water. And there was. So he established a correlation. There could be some, maybe that pump and the cases of cholera are related. And then they went and studied it and established the causation. Just because there's a correlation, there mightn't be a causation. But in this case, there was. So the polluted water was causing the outbreak of cholera. And just to finish a little bit with some jargon there, have you heard of big data? Well, I have examples here of big data. So look, this is what happens on the internet every 60 seconds. And this is 3 years old. So I'm pretty sure it's way bigger now, especially because of lockdowns over the last year. So look, every minute, 1 million photos on WhatsApp, 29 million messages. Every minute, 2 million minutes of calls done on Skype. I'm pretty sure that this has gone down and Zoom has gone up now. 700,000 hours of videos watched on YouTube. You like Netflix? More than 87,000 hours of watched content every minute. And they need to analyze this. They need statisticians to go and make sense of it and try to draw insight. You know, every time you get a Spotify email or a Netflix message like, oh, maybe you would like this movie. You're like, oh, yeah, I kind of do. That's statistics, that's data science, that's machine learning at its best, predicting what you like based on what you've watched before and based on what other people watched. Like 4 million searches on Google. That's why Google kind of knows how to autocomplete your search and so on. And a little bit of AI. What is AI? Well, maybe you've probably seen a CAPTCHA before, yeah? You need to separate yourself from a machine. Well, image recognition is part of what we call artificial intelligence. Many different algorithms that are pure statistics, we can now describe as AI. It's a very trendy buzzword. If you've never tried, you can try Cleverbot. You can talk to a chatbot. It's not real. It's an AI that pretends to be human, right? And see what this, because it learns from what people type. So I asked him, are you human? Yes, I am human. Prove it. And then they said, how would you like me to do that? I said, impress me. He said, come inside my mind and I will. To which I replied, well, that's kind of going well. I was like, how can I do that? Oh, by emailing me a picture of you. I was like, oh, wow, that kind of sounds like somebody talking back. And then I said, what's your email address? And they replied, fantastic. I was like, of course, it's a bot. It's a chatbot. It's an AI. And then this is one that I did a couple of days ago. Prove that you're human. Can't. Why? I don't know how. So it's kind of a little bit better. That was the latest interaction. Just to finish here, if statistics is a crack on the wall, if you make a painting out of it, maybe you can call it machine learning. And when people actually pay to see it, that's AI. That's how trendy the buzzword is. Okay? But it is all based on stats. It is all based on maths. Just to finish here, we do have a maths degree in Maynooth. We have a stats degree in Maynooth and also a data science degree in Maynooth for anybody who likes maths, stats, data science. So we have pure mathematics and applied mathematics. We have a stats double honors degree, so you can actually do something like I did, because I did biology, but I studied stats on the side. You can actually do it formally in Maynooth. You can do a double degree in stats and biology. Yeah, there's plenty of students that do that. You can do stats in chemistry, stats and applied maths, and so on. And also a denominated entry, data science. If you wanted more information, you can go to this website. That's our Department of Maths and Stats. There will be an online open day on the 26th and 27th of November. I will probably be there telling a little bit more about our programs in detail, if you'd like to participate. So if you're planning on doing science in Maynooth, this is what year one could look like for you. You need to pick 4 subjects here. Mathematics is mandatory, so 3 more out of these, including data science. Yeah. So even if you don't like statistics or you don't like mathematics, data science is great because it teaches scientists how to make sense of their own data. If you're going to do science, you will collect data at some point, or you will have to interpret data at some point. So if you have statistics knowledge or data science knowledge, that will be a great advantage to you. And
Rafael, could I ask a question there? And
yes,
it's one that I'm often asked. And when people are asking me to explain data science and the role that it plays in, say, a lot of examples are the US elections with Donald Trump.
Cool.
And then, but that's, I suppose, a negative. But would you mind explaining how the data science was used in helping Trump win the election? And then more recently, and I suppose more importantly, its role in the fight on COVID. Sorry for just throwing this on you.
No, definitely, yeah. So that's a great point, Ita. Thanks. So in terms of the Trump election, so it was related to the Cambridge Analytica scandal with Facebook, right? So what happened is they looked at Facebook posts and using, actually there was a Facebook quiz that when somebody took that quiz, it opened up possibility of gathering data from everybody who was their friends. So typically data that was supposed to be protected by Facebook, there was a certain point of entry there where people could get data. By getting that data, people developed, in Cambridge Analytica, they developed some algorithms to try and identify through the posts that those people made and so on in their profiles, who was likely to vote for Trump, who was likely to not vote for Trump, and who was in the middle. So they targeted those people who were in the middle by doing a campaign against Hillary and pro-Trump to try and turn their votes. So this is an example of data science being used for evil. I kind of like to quote Marvel Stan Lee on Spider-Man, right? With great power comes great responsibility. So yes, statisticians do have superpowers and they can be used for good or for evil. So it's up to us to actually make sure to turn it around and use it for good. But yeah, so you can target a fake news or attack campaigns to people. So this is all about targeted advertising. It's targeted advertising being done for evil in a way, okay? And so you let people decide for themselves. You don't target them because they're on the fence to try and bring them one way or another. If you go on Facebook and if you keep scrolling, you see ads, and they're targeted because of your age, your gender, where you live, and so on. So that's what they did in terms of turning an election around. With respect to COVID, data science and stats were there and are still there all the time. So if you've seen the latest pronunciation, the latest announcement by NEFIT and the government, they're saying, okay, so we were going to reopen everything in 22nd. We're going to pause it. We're going to do it like this, take a little bit differently. That's because the maths modeling is predicting another outbreak of cases. They're trying to not overload the public health system. And that's pretty much what it's been about from the beginning, not overloading public health care, not overloading those systems. Because if they have 10 beds, typically 5 of them are occupied in any one time. But now 6 of them are occupied only with COVID patients, then there's going to be a shortage. So that's the idea, and that's how data science can be used, we can predict how many cases in the future and try to act in advance. It's just like, if we knew this was going to be this bad, I would have done this. That's our job here. We're going to tell you so you know, and then you can act.
And thanks a million, Rafael. And, you know, as we said at the very start, it was when I first heard your open day presentation in April, I was thinking, oh God, goodness, I want to reapply as a mature student to the CEO. Have I to be, like, I was really, really interested. No, I did get a wee bit of a nightmare when you showed up a diagram and it just brought me back to the Leaving Cert Hall in Monaghan when I took my maths Leaving Cert. But if I was interested, because data science is, I think, the highest earning graduate job coming out of the States at the minute. Now, I would always say go into a career that you enjoy, not just for money. But if I was reapplying, do I need to be that A1 or a higher 1 level student with my ability in maths? Or can I be coming in an average? And now that you've whetted my appetite, because I'm coming in with an average maths, ordinary level or honours level, would I be able to become a data science? As in, would I have the capability or ability to succeed in a degree in it?
Absolutely, and I can tell that because number one, I believe anybody, and absolutely everybody is capable of this. And if you put a goal, if you set a goal in your mind, by all means, you can learn it. We do have a higher diploma in data analytics here in Maynooth. All we require is that you have taken some mathematics at some point, because we use some concepts of derivation, integration, calculus, functions, and matrices, and so on. But we do accept students who take a summer course on matrices, linear algebra, or something like this. It's just a certain basic level. And if you're getting started with us in an undergrad program instead of the HDIP, by all means, you will learn all of that in year one. You will take linear algebra and calculus in year one, because that is actually mandatory for every science student. So yeah, yes,
that's brilliant, Rafael. And I suppose the importance there is, and I've done a recent study of some undergraduate students in the maths and stats and science departments in general, and one of the someone who came into MH201, and you did say that they had to study maths in first year, and this person really didn't want it, but they had to do it and thought, okay, I'll just do it for first year and then move over. But then they went on to do a PhD in maths, because they found that maths mightn't have clicked with them in second level, but they really got an appetite by an enthusiastic lecturer. Now, they didn't name you, but my hunch is that it was you, Rafael. But it's so important to come in with an open mind, and an inspiring lecture could, you know, really whet your appetite to go further in maths. I've talked enough. I want to ask our remaining, we will finish on time, but I'm just, you know, we've still a lot of people online there. Has anyone got any other questions that Rafael could answer? And I'd be genuinely interested in too. If you want to raise your hands, and hopefully I will have figured out that I know how to answer it.
Just before we start, Killian, I'd just like to finish by just saying,
sorry, yes, of course.
Yeah, no, sorry. Just like to finish by saying, look, number one, you could spend millions on data collection, analytics, and advertising, or there you go, targeted advertising at its best. Hold a baby lamb in West Kerry, and of course we did hold the baby lamb. That's me and my wife. So that's it. I'll take any questions.
Oh, that's brilliant, Rafael. I'd like to thank you anyway, just from my point, but I do see we have a question. Oh, thanks a million, Aisling. Thank you for your message, and it was great to have you here. If anyone has any questions or wants to raise their hand. We don't have anyone, but I would like to say that we will send a link to Rafael's YouTube channel, but also we're recording this. So once we get it up, I've got everyone's email address. I can send them. Please feel free to send me an email after this. Oh, I think Vivian, you have your hand up. Now, how do I do this? If I could find, yeah, sorry, Vivian, I'm on, yep.
So if you did statistics in college, could you get like a job at like Netflix or something doing it?
Yeah, by all means. Thanks, Vivian, for your question. Yes, you can. So if you actually go to jobs.ie and type in data science or type in statistics, you're going to see the plethora of different job offerings at the moment. So yes, it's always a very sought after skill, and you can get a job in Netflix, the likes of Netflix, Spotify, Google, Facebook, any of the social media platforms, Twitter, and so on. Yeah.
And there's huge employment opportunities, and a lot of those companies that you mentioned, Rafael, have headquarters in Ireland. I've got a question here, Rafael, and I'm not sure you're willing to answer this one, but it's from Alva, and it's, how did the card trick work?
Oh,
controversial.
How did it work? Well, I can tell you how it didn't work. I can tell you that Aaron and I didn't set it up in advance, but I can give you some clues. So it could involve some sort of stack, and it could also involve some sort of AI. So those are the clues I'm going to give.
Brilliant. And actually, Aaron, do you want to give a shout out to your school? And actually, Vivian, do you want to give a shout out to your school, because you're both asking or nominated there?
Thank you very much, from St. Joseph's.
And St. Joseph's is where, Aaron?
Rush County, Dublin.
Oh, brilliant to join you. Thanks a million for joining us. And Vivian, whereabouts are you from?
Well, I don't think Vivian is there.
No. So we have, I think we've a good few messages of thanks, Rafael. But on that, everyone's got my email address if you have any questions after this, and I can hound Rafael for the answers because I won't know all the answers. But I'd really like to thank your time and thank Rafael. I'm going to hand over to you, but for the last final word, Rafael. But thank you so much from Maynooth University Admissions Office for giving up your time and putting this on.
Oh yeah, perfect. No, I was just replying here that there was a question if we had an MSc in maths. We do. We have an MSc in maths, and we also have PhDs in pure and applied maths, data science, and statistics. Well, just like to thank everybody for participating. Thank you very much. It was great to be here with you, and I hope to see maybe some of you next year when you apply to Maynooth. So.
Brilliant, and a big shout out to Mount Sackville, Tullamore College, and everyone who has put a message there. And thank you all very much. And we will send the link once we have it uploaded. Take care. Have a great day.
Thanks, guys.